Today we're going to do our second lesson in from Chapter 9, Theoretical and Experimental Probability. So we're going to learn how to find experimental and probability and to predict future events today. So first up, we have some vocabulary. I hope you guys got the email with my Google Slides notes for Chapter 9. So these definitions will all be in there for you. Again, if you ever want to take any of your own notes, you are more than welcome to as well. But so there is going to be a Google Slide that I add on to with every lesson. Just any important information from the lessons that you might need, all organized in one spot for you. So we're going to talk a little bit about the uniform probability model. That is when each outcome has an equal probability of happening. So that's what our events today are going to all entail. So yesterday, we really actually working with something called theoretical probability. Theoretical probability is what should happen when conducting a probability experiment. So if I have a coin and I have heads and tails on it, in theory, I should get heads 1 out of 2 times, and I should get tails 1 out of 2 times. But when I actually flip a coin 2 times in a row, I might not get heads once and tails once. What actually happens is my experimental probability, and it's kind of hidden there, so let me hide that. So experimental probability is what actually happens during a probability event. So if I flipped a coin 2 times and I got heads 0 times, then my probability of getting heads would be 0 out of 2, not 1 out of 2. So theoretical probability is what should happen. Experimental probability is what actually will happen. So let's look at quickly those differences a little bit here. So if I have a graph of my spinner results, so I spun it 60 times, I don't need to add those numbers all together because it tells me right in the problem that I spun it 60 times. And there are 3 equal sections. So I want to find the experimental probability for spinning red in this experiment. So when I look at this on here, it shows me that red was 24. So I could say that my probability was 24 out of 60. That again is the experimental probability because that's what happened actually when I did my experiment. However, I always want to simplify that down. So I could say that when I divide top and bottom both by the greatest common factor of 12, I would get 2/5. So I have a 2 out of 5 chance of getting red based on what actually happened when I did my experiment. Sometimes it's easier to convert these to either decimals by doing 2 divided by 5, or to turn that decimal into a percent when I want to be comparing multiple things together. So I'm going to convert this to 40% just for ease of looking at it. Now, if I want to know what the theoretical probability would be, well, the theoretical probability is what I expected would happen. So if I have a green, blue, and red spinner in 3 equal sections, red should have come up 1 out of 3 times. 1 out of 3 is 0.33 rounded, or 33%. So when I look at this, my experimental probability, I'm just going to say EX for experimental probability, was actually bigger than my theoretical probability should have been. So I can say that experimental probability, the 40%, was greater than my theoretical probability of 33%. Let's practice another one here real quick. So now they rolled a dice 50 times. So I want to find the experimental probability of rolling a 4. If I look at my graph on here, 4 goes in between the 8 and the 10 line on there. So I'm going to think that the 4 is at a 9. So I could say that my experimental probability is 9 out of 50. If I double that, that becomes 18 out of 100. So I know that this is 18%. So my probability of getting a 4 was 18%. But my theoretical probability was what I would have expected to happen. So if I have a regular number cube, the probability of getting a 4, like we practiced yesterday, would have been 1 out of 6. 1 out of 6 is actually going to be equivalent to about 17%. So again, my experimental probability, I could say, was greater than my, wrong button there, greater than my theoretical probability. So experimental probability was based on what actually happened. Theoretical probability is like the probability that we did yesterday. How does this help us though? This can help us if we want to predict future events. So if I look at this on here, a survey of Mrs. Ramirez students showed that 30 students will have pizza for lunch, 17 will have mac and cheese, 12 will have hamburger, and 5 will have chicken fingers. Suppose Mrs. Ramirez surveys all 1,200 students in the school. How many students can she expect to choose hamburgers for lunch? Well, if I total up the 30, 17, 12, and 5, I do get that there are 64 total students. So what I could do is I could first write the probability of both of the students, all the students that chose hamburger from her survey. So I can write 12 over 64. 64. That could be one probability. But if I want to make that for out of 1,200 students, I can set up a proportion to find my equivalent ratios. So I can say on here that 12 over 64 equals some unknown number over 1,200. So going back to how I would solve my proportion, I can multiply across my diagonal and then divide by my last number. So I could do 12 times 1,200, and then I could divide all of that by 64. When I do that, I would get 225. So she could expect 225 students to choose hamburger for lunch. For our last problem, you guys are going to be answering this one on here. I had to make a quick edit. This was screenshotted from the book and they had a typo, so I couldn't change it, but I just changed it to say the correctly spelled times. But if I have a spinner that's in 4 equal sections and I spun it 100 times and it lands on green 32. So you click on it. Oop, actually, that's selected, so I click. Okay, I get orange. Get red. And if I were to do this 100 times, keep track of my data, and I got green 32 times. So you guys are going to be telling me what would be the experimental probability. You can tell me as a fraction, decimal, or as a percent. But I also want you to tell me what the theoretical probability would be and how they would compare. So hopefully that all makes sense and you guys are able to tell me all that. You guys will be doing a probability lab today where you guys will actually be using a spinner online to conduct a probability experiment and answering some questions on the book website as well. Hope you guys have a great day. I think our office hours are scheduled at 1:30 today, so hope to see a lot of you there. Bye.